So in the last video, we looked at different words that would give away key features of what we were after in word problems. Now, this is only like the bare minimum, what you see more times than not. However, the more word problems you can do, or the more word problems you do, you can go in and like fill in these notes with the words that give it away about what key feature you were after. So the way I like to do word problems, guys, I'm different than most people. I like word problems more than I like non-word problems, because at least with word problems, I get to talk about something in a context and make it make sense versus it just being letters, right? Letters make up of words, words make sentences, sentences make paragraphs, paragraph makes pages, pages make stories, okay? Tell me a story, okay? And that's essentially what happens here. Now, whenever I'm presented with the word problem, there's a couple. I like to use this box. I like to write down what I'm given, what I want to know. I like to show my work on one side and then just always clearly put the answer over on the right. Now, again, I'm a little bit different. I like to start with the end in mind. What I mean by that is the first box of these four I like to fill out is what I want to know. Okay, 9 times out of 10, what you want to know, right? That's the actual question to the problem. Is going to come at the end of the story. Okay, so I find question marks. So I'm just glancing over it, I'm like, oh, a question mark right here. All right, so I'm going to follow this back to the start of the sentence. Now, I can write all of that I want to know inside this box, but at the end of the day, there's only a couple of these words that I'm interested in, right? Because I'm going to be looking for a key feature: max, min, solutions, roots, axis, symmetry, vertex, or some kind of distance. So I'm going to read it. How many centimeters of rain will produce the max number of mosquitoes? And bingo, there it is. All right, I want max number. I see the key feature there, which is max. So that's what I'm interested in. So the max. But now what about the max? Okay. Is it max number of mosquitoes? Or is it rain to get max? So this is where, like, going back, having options, and then seeing what the question is really asking. Who, what, when, where, why, how, right? Frames up questions. How many centimeters of rain will produce max number of mosquitoes? So I want the amount of rain to get my max. Now, I go back and I start working on my given. Now, if I'm given a page, if I'm given a paragraph, if I'm given 3 sentences, it's a lot more than what I really need. Okay, so I know in my mind I need something that talks about mosquitoes, and I need something that talks about rain. If I'm not given that, I'm going to try and get rid of it because it's just extra information that's just going to be wasting my time. So you're going to see me like kind of shade this stuff out. The number of mosquitoes in Anchorage. Okay, so I got mosquitoes, so I'm going to leave it. Alaska in millions as a function of rainfall in centimeters is modeled by blah. Okay, so the number of mosquitoes, right, again, like again, a little bit different. Mosquitoes, I don't care where they're at. Millions talks about the quantity of mosquitoes as a rainfall. This is what it's measured in, which is good, right? Units is good, is modeled by equation. So I wasn't able to eliminate a ton of stuff, but I now know the context and what my problem is, okay? So I'm going to be given mosquitoes in millions. Now what this means, if I see 1, that really means 1 million, okay? So my scale on my graph I wind up creating really would, 1 really means 1 million, okay? As a function of rain, okay, now I know that rain, and it's measured in centimeters. So again, an example, if I see 4.5, I know that means 4.5 centimeters. Okay. Now last but not least, I'm given m of x is equal to negative x squared plus 14x. Now, f of x, m of x, p of x, q of x, s of x, t of x, q of x, r of x, p of x, I don't care. Something of, okay? I'm actually going to bring this over here. All right, m of x, at the end of the day, guys, is just my y. And then x's are just x's, okay? All right, we can always take this back to a graph, and I actually suggest doing this as well. I have my x-axis, I have my y-axis. X is rain centimeters, y is mosquitoes in millions. All right, so I have all of this, and again I'm looking for the max value of my function to begin with. All right, so I have my function m of x. Negative x squared plus 14x. Now I need to zoom out until I can see my max value. Well, there's my max value. Okay, so this time I was really looking for the vertex. Okay, so I have the 0.749. So the graph looked something like this. And again, remember, I was interested in the points, right? So we have all of these different key features of the quadratic. Now, of all of these, this is what I was interested in, this point right here. Okay, because it's going to tell me something about my max. Now, what does this point mean? Okay, this point means that at 7 centimeters of rain, comma, we have a max value of 49, and I'm not just going to write 49, but I'm going to write 49 million mosquitoes. Now, of this point, we wanted, right, the rain. So I want rain. And then that's my answer. So 7 centimeters of rain will produce max number of mosquitoes. It's not asking how many mosquitoes, it's asking for how much rain is going to get me the most mosquitoes.